So once we've listed out all the terms here, when we group these together, I'm going to get this sum is going to end up being, when I do the addition or the subtraction of fractions, I'm going to get a common denominator, which is 1 times 2, so I get 1/2. The common denominator here is going to end up being 3 times 4, and because they differ by 1, we're going to end up with 1 over 3 times 4, which is 1/12. So there's actually a pattern to this. Okay, this becomes 1 over 5 times 6, 1 over 7 times 8, 1 over 9 times 10, and 1 over 12 times, it's going to be 11 times 12, and it goes on and on and on. Okay, so one thing we can say though is that, and we list out the Basel series here, and one thing we can say, because this is infinite, is that there is a 1-to-1 correspondence here. So this sum here of 1/2 and 1, there's for every one of these, there's one of these. For 1/12, we can pair it with 1/4, 1/30, we can pair it 1/9, and we can do pairs like this all the way down infinitely. And we can see that up to here, our partial sum is going to be 0.6628. Here, our partial sum is 0.1527. I think the sum ends up being about 0.6, a little bit over 0.6 if we go infinitely. But we know this one converges. And if we have a 1-to-1 correspondence here, and what do you notice about the 1-to-1 correspondence? This green sum, this green term is always smaller than this blue term. Okay, for every single pair. If that's true, we can do a 1-to-1 correspondence here all the way to infinity, and that's true infinitely. If this sum converges, and every term is less than the corresponding terms in the blue, we know that the green sum must be less than the blue sum. In fact, that's true. And when we do the decimal calculation here, we can see that, yeah, it's in fact up to here, it's actually quite a bit lower. And as we keep going to infinity, it's going to be, it doesn't, because of the 1-to-1 correspondence, this term's always going to be smaller than this one. This one's not going to grow as fast as this one. And this one is finite. This one must also be finite. So we're making an argument here for the finite nature of this alternating harmonic series. So what we can then say then is, based on the observations here, that since there is a 1-to-1 correspondence in the table, there's a 1-to-1 correspondence in the table, and this continues infinitely. Okay, this continues infinitely. And furthermore, the harmonic sum, and it should be more clear, the alternating harmonic sums are alternating harmonic terms are smaller it must converge. Okay, so that's an important thing. This is a reasoning that we're going to start using. We're going to use these comparison arguments. We know this one converges. We know this one's smaller, so that green sum must also converge.